Depth charge here for another math tutorial video, and let's get to it. So today's topic is going to be long division, and specifically long division of polynomials. But before we start long division of polynomials, let's review some elementary school math material, and that is long division with just plain old numbers. So here we have 67 divided by 3, which the calculator can do for us, but we're going to not use calculators today. 67 divided by 3, we should know this is not going to be a perfect division. 3 does not perfectly go into 67. And so to do that, we perform long division, where 3 is on the outside and 67 is on the inside. There's lots of terms that are used to describe this, or the description varies. You put 67 within the house or within the box. Regardless, 3 is divided into 67. And so it's a multi-step process of division, multiplication, and then subtraction. And we don't divide 3 into 67 directly in this handwritten non-calculator method. You divide 3 into 6. And that divides perfectly. It divides and you get 2. 3 divides into 6 and you get 2. And then you multiply. 2 times 3 and you get 6. And then you subtract. When you subtract, you get nothing because it's a perfect division. Then you drop the 7. And the 0 is not needed because we have 7 here. Then we repeat the process. 3 divides into 7 and it divides into 7 a grand total of 2 times. So this next step is tricky. This 2 has been used, now this 2 is going to be used. This 2 is going to be used in multiplying this 2 by this 3 to get 6. And then you subtract again. Like I said, it's a repeating process. You subtract again and you get 1. That is the evidence we need to show what we already knew, which is the division is not perfect. So what is this called? This is called the remainder. Well, what do you do with the remainder? What you do with the remainder is you put it above what you are dividing into 67, and you get a fraction. So, well, that's great. We just actually solved it. We got it, and what this should be is 22 1/3. And what we should know, we actually are going to check it with the calculator. We didn't actually use the calculator to do it. We're going to check it with the calculator. 67 over 3 is, look at that, 22 1/3. So if we'd want to, we could actually do 22.33 repeated. That's great. But like I said, this is not needed. This is good to go. We call this the remainder. So we did a little elementary school material as a review of dividing one number into another. This method did not require a calculator. This next method is the same method. Let's go. There we go. Sorry for the delay. This next method is the same method of long division. Long division is a very specific type of division. And long division is as follows. So there's my division, written out from left to right. There's my division where I use this method of dividing the expression into another expression. Now it's done a little bit different, but not by much. And that is, I divide x into x squared. Before I was dividing 3 into 6. Now I'm dividing x into x squared. And it divides perfectly, and I get x. And we know it divides perfectly because x times x is x squared. Now what's done a little bit differently is that this is not a singular number, it's actually an expression, x minus 1. And so when I multiply x times x to get x squared, I actually then also multiply x times 1. And that gets me 1x, but it's negative, keep that in mind. Now I do the subtraction, just like before I do the subtraction. And I get nothing when I do this subtraction. I don't get nothing here. I actually get negative 7x minus negative 1x, which is negative 6x. Because subtracting a negative is actually adding a positive. Then I drop the 6. Awesome. X divides into negative 6x, negative 6 times. And you know that to be true because negative 6 times x is negative 6x. Notice I have the same thing on top of itself here and the same thing on top of itself here. Very important. Now, I'm not done multiplying because I'm actually multiplying negative 6 times x, gives me that. Negative 6 times negative 1 is positive 6. And we subtract. And look at that. We get a grand total of nothing, which means this is a perfect division. There is no remainder. Is this still the remainder? Yes. Remainder. Awesome. So what does that mean? What it means is that this quotient is done, which means I can write this as x minus 6 because it's perfect. Done and done. All right, last one of the day. This last long division will most likely have a remainder because the previous one had no remainder. So it's the same method. Got the small thing here, divided into the big thing. There it is. X divides into x squared just like before. And we get x. X times x is x squared. But you have to multiply again, because it's not just x times x, it's x times 2, which is plus 2x. This next step is very important. It's a little bit different, like I said. Before, let's review again. Before, it was just a singular thing here, because 2 times 3 is 6. Now, it's x times x is x squared, x times 2 is 2x. You subtract, and you get negative 3 minus 2x. So this is nothing. So negative 3 minus 2x is negative 5x. Then we drop plus 7. Drop the plus 7, and there it is. Now we divide again. Repeat the process. X divides into negative 5x this many times because negative 5 times x is negative 5x. That verifies the quotient. This dividing into this gives me this. I multiply again and I get negative 10. Negative 5 times 2 is negative 10. Now we're going to see through this subtraction that we get a remainder that's not 0. This is nothing. 7 minus negative 10 is actually positive 17. So what do we call this? We call this the remainder. So what does that mean? That means that the quotient, the final quotient, is this. There it is. The final quotient is this. Well, what does that mean as our final answer? This is perfectly fine as a final answer. Notice that the 17 is divided by the original thing that is being divided into the big thing. And so I can write my final answer as follows. And it should hopefully all fit on the screen. This quotient comes out to this right here. This is my final answer. And the remainder is 17. Questions that will be asked of you on lots of different math courses, high school and college, is that here's the division, what is the remainder? And the answer would be 17. The actual quotient gives you this, which is the end result of the division of one expression by another. Hope you enjoyed this video. Please check the description and look at my other channels. Hit the thumbs up and subscribe if you would like, and I really appreciate the support. Depth charge out.